So we had a lot of questions on 11, 13, and 15 from the homework, so I thought I'd just do a quick video on those three. So 11 is balancing a chemical equation. It does have this square brackets m at the beginning of the problem, which means that you should be using technology, and really, as far as I'm concerned, you should use technology on all of them, but it tells you this one's going to be a little bit beefier. So we've got these chemical equation or reaction here to balance, and as you count through this, we've got 1, 2, 3, 4, 5, 6 different elements, and I think, like I said before, I usually just take them in the order that they come in the equation, although you can really do them in any order. So just knock these out. O and H. There's the 1, 2, 3, 4, 5, 6. Okay. So the first vector of our matrix is going to be this first compound here. So we have 1, 1, and then 0 of everything else. 0, 0, 0, 0. And we know that's going to be like the first vector, but really we're going to end up combining these vectors into a matrix and then row reduce the matrix. So I'm just going to go ahead and start putting it in matrix. So the next one here has 0 of that, 0 of that, 2, 10, 35 oxygens, and none of that. Okay, the next one, 0 does have 1 there. 0, 0, 4, and 2. These other 4 are on the other side of the equation. So keep in mind as we move them over and combine them into the same side of the matrix, that they'll end up being negative. So that'd be -1 there. Let's see, none of that, none of that, none of that. So 0, 0, 0. Oxygen, -4. And what's left? Hydrogen. So -1. The next one, 0, -3, and then just oxygen. So 0, 0, -12, 0. The hardest part for me on this is that just keeping track of which row is which element. And let's see, then we got some water on the end. So 0, 0, 0, 0, 1, or -1, sorry, and -2. This last row of zeros isn't strictly necessary, but it helps me keep track of what's going on, that this really is equation, and I've really moved everything to one side. So on the other side now, it's just, this is an augmented matrix. Everything is equal to 0, so this is a homogeneous equation. So we just need to row reduce this, and you can see why you definitely want to use technology here, even if you weren't doing it otherwise. So you dump all this into your favorite matrix calculator and reduce, and you get this output. Let's see if I can drag this down a little bit. Yeah. Get this output, and just to save time, I'm not even going to write the whole thing down, but keep in mind what this would mean is this would say 1x1, so 1x1 minus 16 327ths, 327ths of x7 equals 0. So there's x1, x2, x3, x4, x5, x6, x7, which is going to tell us how to combine our seven molecules here. So you would do the same thing with all the other equations. They're all pretty straightforward. X2 is going to be minus 13 327ths of x7 is going to equal 0, and so all the way on down the line. So I'm not going to write all those out. Let's just finish kind of doing the x1. So this would say x1 actually equals 16 327ths times x7. And you do the same thing for x2, x3, x4, x5, and x6. Notice that that's the end. There is no equation that is going to say x7 equals. So that's a free variable. If you really want to be fully explicit about the solution, the very last line would say x7 equals x7. That does mean you can pick x7 to be whatever you want. Again, we like to have chemical equations balanced with integers instead of fractions. So my particular choice for x7, I think, will be, let's let x7, since it's free, equal 327. That will clear out all of our fractions. And based on that choice of x7, x1 will turn out to be 16. And you could practically, and you don't have to write the rest of them down here, you can see that x2 is going to end up being 13. Oops, x2 is going to be 13. x3 is going to be 374. And I won't finish out the other three, but x4 is going to be 16, x5 is going to be 26, and x6 is going to be 130. So as you go back to your original equation, if you really want to write the balanced equation, x1 is 16, so you'd say 16 there. x2 is 13, so 13 of that. And x3 is, you need a whopping 374 of that one. And then fill in the x4, x5, x6, and keep in mind we chose x7 to be 327. So let's see, what were those others? 16, 26, and 130. So 16, 26, 130. Okay, so kind of a big, messy matrix, but comes down to the solution. Definitely a solution you would not want to work out just by guess and check. So that's number 11. Let's move on to number 13. Okay, so 13 is a network flow problem, and the basic idea is to look at the locations, the intersections, and say whatever goes into the intersection must be equal to whatever goes out of the intersection. So starting with location A, say what goes in is going to be 30 and x2. So, oops, let's get on the right layer. So 30 plus x2 is going to equal what's going out of that intersection, which is x1 and 80. And we know that we would like all the variables on one side and all the constants on the other side eventually, so let's rewrite this as negative x1 plus x2, so moving the variables to the left and numbers to the right, so equals, subtract 30, so equals 50. So we would go ahead and do this for the other four. Well, we got 4 more intersections to do. Maybe I'll just pause the video as I write those out, and I'll be right back. Okay, so we've got all the intersections expressed as equations, and the equations over here kind of in the format you would need to dump them into a matrix. And again, I did go ahead and put those into a matrix and reduce it, and you get some free variables. So there's an x pivot in x1, there's a pivot in x2, no pivot in x3, so x3 is a free variable, so is x6. But let's take a look at what some of these equations mean for us. This first row says x1 minus x3 equals negative 40. So let's see, I'm going to jot that down up here. x1 minus x3 equals negative 40. I'm actually going to solve this for x1, so it would look like that. Tells us that there's lots of possible answers for x1 based on what we pick for x3. We can do the same thing with all the others. You say x2 is going to be, move this to the other side, x3 plus 10. x4 is going to be x6 plus 50. And x5 is going to be x6 plus 60. And I'm not going to write the rest of those out, but notice they say, assuming the flow must be in the directions indicated, so basically no negative flow. If the arrow's going that way, that says you have to have positive going that way. There's really no danger of having negatives from any of the equations except for this first one. So for the first one, the most minimal flow you could have would be if x3 is 40. And that means x1 would be 0. And later on with the other equations, it turns out you can choose x6 to be 0. And that will give you minimal flow on the other equations. So I realize I'm not finishing that, but I think looking at the answer in the back of the book, I think hopefully it can make sense with what I've done here through to the answer at the back. All right, let's move on to number 15. So 15 is also a network flow, so it's going to be pretty similar in style. We'll just start with, there's what, A, B, C, D, E, F. There's 6 intersections. We need to write down an equation for each one. So for the first intersection A, the flow that's going into it is both this feeder from the side, so 60. Let's get on the right layer again. So 60 is going in, and also x6 is going in. And what's going out of point A, node A, is just x1. So in a similar style for node B, intersection B, what's going in is just x1. What's going out is x2 and 70. For C, what's going in is x2 and 100. And what's going out of C is just x3. For D, coming in is x3. Going out of D is 90 and also x4. Getting there. Going into E is 80 and x4. So x4 and 80, and going out of E is just x5. And last one, last intersection, F, coming into that is x5. And going out of that is 80 and x6. So 80 and x6. So again, for matrix-friendly format, we want to move all the variables to one side, all the plain numbers to the other side. So first equation is going to look like, that's a terrible negative sign, that's all right, negative x1 plus x6 equals negative 60, and the next one will be x1 minus x2 equals 70. The next one is going to be x2 minus x3 equals negative 100. Let's see, the next one's going to be x3 minus x4 equals 90, and then we have x4 minus x5 equals negative 80, And the last one will be x5. The columns aren't quite lined up here, but x5 minus x6. We'll have slightly bendy columns equals 80. So we will turn this into a matrix. We will row reduce, and hopefully we'll find solutions. Since they're saying find the smallest possible value for x6, that makes me think there might be a free variable in there. We have some choices about the solutions. But let's take a look at how this matrix actually row reduces. Okay, so translating all that into matrix and reducing the matrix gives us something like this, and then we start putting the variables back on. So the first equation in the reduced result says that x1 minus x6 equals 60. And again, as we actually start talking about the solutions and what is x1, we will solve this equation for x1. So x1 equals 60 plus x6. The next line will be x2, and I'm going to move the x6 to the other side. So x2 equals negative 10 plus x6. Notice we're moving x6 to the other side every single time. But notice all of the other numbers on the right-hand side are either 0 or they're positive. So when they say find the smallest possible value for x6, x6 would have to be 10, at least. That would mean x2 is 0, but we don't want x2 to be negative. People should not be driving backwards in the roundabout. So x6 being at least 10 will prevent us from having any accidents over here. I guess x6 being 10 means nobody is driving between B and C. Everybody's apparently exiting the circle at B, but that's okay. And again, I'm not completely finishing the problem, but you have the answer in the back of the book, so you can see the full answer. But hopefully that answers questions on those three problems. Hopefully that was helpful. If you still have questions, please let me know.